All right, it is 12:30, so we will go ahead and get started. Hello, everybody. My name is Sarah Sims, and I'm the Assistant Director for Professional Development for the Brown School here at Washington University in St. Louis, Missouri. Thank you all for joining us for today's Open Classroom program. For those of you who aren't familiar, Open Classroom is our free professional development webinar series. Beyond Open Classroom, we have lots of continuing education opportunities that I would invite you all to, which we'll be speaking about a couple of those later in the session today. But the QR code on the screen will take you to our homepage where you can discover many more opportunities to learn with us. Just a few housekeeping items before I officially start the program today. So the first is, as you may have noticed, this is a Zoom webinar, so we can't see or hear anyone. Also, if you raise your hand, we can't acknowledge raised hands, but we have turned on the chat, and many of you are already using it to say hello, and we hope that you continue to use it throughout the program today. There will be a little bit of time at the end for question and answer, and so that's how we will take those questions. If you put those into the chat, we'll field them that way. And we certainly hope you do that. Also, today's program, as you may have noticed, is being recorded, and that recording will be posted at our website sometime tomorrow, as soon as I finish editing it. So if you have to miss part of it, have to leave early, have a colleague who was unable to watch today, you can direct them to watch there. All right. So without further ado, we are ready to get started. So it is my pleasure to welcome and introduce my colleague, Dr. Ruopeng An. Dr. An is an associate professor and faculty lead in the public health sciences at the Brown School and faculty fellow for AI innovations in education at the Office of the Provost here at Washington University. With over 200 peer-reviewed journal publications, Dr. An is a prolific author and has been recognized as one of the top 2 most cited scientists in Elsevier. His research has been featured in Time, the New York Times, the Los Angeles Times, the Washington Post, Reuters, USA Today, Bloomberg, Forbes, The Atlantic, The Guardian, Fox, NPR, and CNN. He was also elected a fellow of the American College of Epidemiology and the American Academy of Health Behavior. He teaches applied machine learning, applied deep learning, and generative AI courses, which attract a high caliber of graduate students from across our WashU campus and medical school campus. He also leads a professional development advanced learning certificate course on AI, which we are offering again this fall. We're very excited about that. We'll share more information later. And so that's just a small list of his many accolades and accomplishments. So I'm very pleased to welcome Dr. An, who is here today to present Reimagining Qualitative Research with Generative AI. So I will turn it over to you, Dr. An.
Thank you so much, Sarah. It's great to see everyone. We have really diverse of researchers, students, practitioners across the states. I'm so amazed. So let me share my screen. And we enlarge this. So it's going to be a wild journey. We have only 1 hour, and I try to put as much information as I could. So we will go really fast. So I apologize if the pace probably sometimes is fast, but we do want to cover a wide range of topics. But then hopefully we'll reserve some time for the question and answer. If you have any questions, just feel free to post on the chat. And our colleagues Sarah and Zizi are going to monitor the chat, and then at the end of the presentation, we'll reserve some time for question and answering. Okay, so today we're going to talk about how we can utilize artificial intelligence to do qualitative analysis. And the outlines are the following. So we would first talk about the dichotomy of qualitative versus quantitative analysis and try to break it down into pieces. And then we'll talk about the conventional quantitative analysis of qualitative data. And then we'll move on to relatively new text mining methods, but preceding modern or generative AI, and how we can apply that to the qualitative data. And then finally, we are going to move to the most probably exciting part of the talk, which is about providing you case studies using large language models to analyze qualitative data, and we'll perform a variety of analysis, including sensitivity analysis, thematic analysis, ground theory, discourse analysis, and most importantly, data synthesis. Okay, so let's get started. And just a very brief overview of the, I would say, false dichotomy of qualitative analysis versus quantitative analysis. I think this is a false claim, because really what we talk about is in two-dimensional space. One is qualitative data versus quantitative data. The other is qualitative analysis versus quantitative analysis. So in this framework, we can actually break it down, the analysis to 4 domains. We can use qualitative data, qualitative analysis to analyze qualitative data, which is of course the most prevalent approach. We can also use quantitative analysis to analyze quantitative data, basically data that can be represented by traditional numbers or spreadsheet, right? So that is also prevalent that most of us do using statistical approaches. It is rare to use qualitative analysis on quantitative data, but on the other hand, I would say is we have increasing cases that we can use quantitative analysis on qualitative data, which is exactly what we want to talk about in today's presentation. So what are the conventional quantitative analysis on qualitative data? This is not a complete list, but though they give you some essence of what are the probably conventional and common used quantitative approaches on qualitative data. As simple as, for example, word count frequency, word by respondent matrix, some matters about lexical richness, word cloud that we all love, free list and pile counts, pile sorts, and multidimensional scaling, or the MDS, cluster analysis and taxonomy, and also similarity metrics and semantic network analysis. We will go very quickly through the list just to give you familiarity with those traditional approaches. So first is word count and frequency. Basically, word count or frequency is just a matter of how many times a particular words appear in a text. For example, I actually counted because I'm an obesity researcher. I'm really interested in obesity. And the word obesity appeared 34 times in the dietary guidelines for Americans 2020 to 2025. Okay? So that is a matter of the word count representing potentially the importance of a specific term. Word by respondent matrix. Basically, it's just a table showing the occurrence of words across different respondents' answers. For example, respondent A mentioned quality 10 times, respondent B mentioned it 5 times, right? So it is a simple count forming a matrix showing the convergence or the divergence of opinions regarding the importance of certain terms across different respondents or different reviewers. And type to token ratio, it is very prevalently used in traditional quantitative analysis on qualitative data. For example, in a sentence or paragraph, the type to token ratio, the ratio of a number of different words, they are called types. And then to the total number of words, which are called tokens. Okay? So it ranges, of course, between 0 and 1. 0 means, well, there's just a repetition of the single word all the time. Whereas 1 denotes that every single word is different in the sentence or in the paragraph, right? So the ratio reflects the diversity of the vocabulary, or we would say lexical richness used in the text. For example, a child story have a type token ratio 0.5, whereas maybe a scientific article has a type token ratio of 0.6, 7, or 9. Word cloud is everyone loves because it's very, give you great visualization and everyone can understand. So by definition, word cloud is just a visual representation of a word frequency in a text, okay? A verb of text with size indicating the frequency of the word appearing in the text. Okay? So for example, if you create a word cloud of in the environmental report, then of course in the report it mentioned the pollution probably many times, right? And then probably followed by ecosystem, maybe bio, maybe wildlife, maybe greenness, natural resources, etc. Right? So if we produce such a word cloud for the environmental report, it may look something like this. And then free list and pile sorts. So those basically are techniques for eliciting and categorizing items for respondents. So participants can come with a free list of the things they think are important or fall into a domain. And then it's up to the researchers or organizers to sort those lists into piles, denoting a particular domain of knowledge or aspect. And multidimensional scaling is also very a widely used approach to analyze qualitative data. It is a statistical technique that visualizes the relative distances between items in a two-dimensional space. Okay, so it can be used as a dimensionality reduction tool and also used to group the complex and multidimensional concepts into two dimensions, so it's easier to see what ideas go together with other ideas and whether some ideas are further away from other ideas based on the relative distance in this two-dimensional space. I here borrowed Dr. Lindsay Stark, or very professor at Brown School's global health report, and she and her team found that there were three important concepts represented by the massive data points that collected from her survey regarding knowledge and the skills and value. Cluster analysis and taxonomy are the techniques that we group objects based on their characteristics to form usually a hierarchy. Okay? So there are qualitative methods that allow you to present this taxonomy, and there are quantitative clustering techniques as well. So, for example, animal species are clustered into taxonomy based on genetic traits. And on the right-hand side, you will see a lot of machine learning-based clustering analysis. And the most common ones that I could see include maybe K-means, the Birch, DB-scan, and EM. So those are probably the most prevalent used cluster analysis, but there are many other cluster analysis, either form a cluster or form a number of clusters based on the hierarchical order. And finally, the similarity matrix and semantic network analysis. So those techniques can also be done either manually or assisted by some software computing to create matrices that show how similar objects are, and they are usually used to analyze relationships. Right? So you can form a variety of matrices based either on the text corpus or based on individual responses. And then when you assemble a number of matrices, you can form a network. You can either do network analysis manually, or sometimes you can use social network analysis to build network that can represent complex relationship between different entities. For example, a matrix indicates doctor, nurse. They may share semantic closeness in healthcare text. And then let's move on to relatively new text mining methods, but preceding the generative AI. What are those common techniques? Again, this is not a representative list. Okay, this is not exhaustive, but I know I try to pick some of the most common ones, including dimensionality reduction, information retrieval, natural language processing, NLP in terms of traditional NLP, such as part of speech tagging, named entity recognition, NER, disambiguation, pattern recognition, document clustering, co-reference resolution, sentiment analysis, topic modeling, and text pre-processing. So let's go through this list one by one really quickly. So dimensionality reduction is a way to suppress a huge number of variables into a reasonably small number of so-called principal components, so that we can analyze the data quantitatively, using traditional statistical approaches. Right? So we use PCA to, in this case, simplify a data set with multiple dimensions into just 2 dimensions. So basically, we identify 2 principal components that reserve the most variance or most variations in the data, so that we can use these 2 complex variables or principal components to represent the richness of the variables. Information retrieval is the approach of obtaining relevant information from a large repository of text. For example, you can search a database for articles on diabetes treatment options, and the database could be huge with maybe tens of thousands, if not millions of documents, and how you can quickly retrieve that information, retrieve the relevant document, as well as the text extraction from the documents, it is quite a challenging task. And NLP traditionally are used extensively in part-of-speech tagging. The POS, or part-of-speech tagging, denotes the process of marking up a word in the text as corresponding to a particular part of speech. Probably most of you know better know English grammar than myself, but here is a really simple example, right? In the quick brown fox jumps over the lazy dog, jump can be recognized and be tagged as a verb, whereas the fox as the subject. Named entity recognition has a long history. So because a lot of time we are interested in we have a huge volume of text, and we quickly want to get the names sorted into different categories, right? For example, in this text, Barack Obama is a name, and August 4th, 1961 is a date. And American is a location. The United States is a country name. And then the Democratic Party and Illinois State Senate, they are either positions or agencies, right? So basically, you try to get to categorize the words in a bulk of sentences into different categories. So those categories are called entities. So therefore, we can either use traditional statistical programming or use the large language models to extract the names of people and places from some articles. This ambiguation is quite simple. It's basically try to clarify the meaning of words that have multiple interpretations. A classic example is apple, right? Because actually, for human being, because we read the context, it's very easy for us to tell whether this apple refers to maybe the fruit, or that apple actually refers to the company, right? But well, the machine, it turns out to be a relatively hard task for machine to do, because the machine traditionally don't really read the context. But nowadays, thanks to large language model, this is not a huge problem anymore. Pattern identification is also a very traditional way in the text mining, because a lot of time we try to extract certain data based on regularities or rules. For example, if we want to extract all the email addresses, all the phone numbers, all the zip codes, right, from huge amount of data, and then traditional approaches would be used regex, or so-called regular expression, which is a computer language that allow you to write very rigorous strings to represent the pattern in your data, and then use that to systematically identify all the words or phrases that fall into the regex rule. But well, now we have generative AI, and we can use AI to try to understand the rule without explicitly defining the rule in the regex format. Document clustering is another text mining approach that we try to group similar documents together based on content. For example, if you have a million news articles and you want to sort them into either sports or entertainment or politics or I don't know, environment, marketing, etc. And you can use document clustering approach to identify the similarities or the differences between different documents and use that to cluster the document into different types. Co-reference resolution is a way to determine when different words refer to the same entity in the text. So, for example, if in a sentence, the first sentence is about President Obama, and the second sentence is about he, we human are easy to understand this because we read the context. But for machine, it was hard for machine to realize actually he and Obama refer to the same person. Okay? But now again, thanks to the modern AI, most likely it's not a problem anymore. And then another very prevalent and widely used approach in text mining is sentiment analysis, right? Basically trying to assess the emotional tone behind a series of words, right? If the words, I don't know, contain some emotional representation, maybe sad, happiness, disagreement, disgusting, those emotions can be assessed using sentiment analysis. The traditional way that we do sentiment analysis is to identify certain words that represent certain emotions, but of course, no, they are not very accurate. And then we came up with the so-called backwards model, which is the traditional NLP approach, natural language processing approach to do sentiment analysis, basically reading, for example, product into positive, neutral, or negative. Right? But of course, again, thanks to large language model, now we can do a lot more nuanced sentiment analysis than those backwards models. And then topic modeling. Topic modeling is the statistical approach to identify or discover the abstract topics present in a collection of documents. Okay, so here on the right-hand side, we see example that the algorithm identify a number of words, and those words form a topic. Maybe the words of pollution, ecosystem, animal species, they form a topic about environmental protection. Maybe other words form a topic regarding democracy. Basically, we identify those words based on their statistical properties to form topics that can cover thousands of news articles. Okay? But topic modeling is different than semantic analysis because topic modeling just identifies individual words. And you, as a researcher, need to come with some kind of explanation of what those means and how those words form a topic. Whereas thematic analysis basically identify using complete sentences and summarize the topic for you. So these are the key difference between topic modeling and semantic analysis. And then text pre-processing, which actually 3 years ago, the majority of my work using NLP to analyze text data was through text pre-processing. We have to get rid of those stop words. We have to get to put the words in using either lemmatization or stemming to reduce the dimensionality of the words. And then we have to maybe removing the punctuation, etc., and maybe special characters to make the text clean and analyzable. Okay? But again, now in the wake of general AI, you usually don't want to do that. You don't need to do that because we are moving away from the traditional backwards model that you have to clean the data. Now, usually we don't think it's a good approach to ever clean your data because by cleaning, you actually are reducing the information. Some of the information, for example, a smiling face, could really represent a very, very important emotional character, right? So here, for those of you who are not in this domain, there's a difference between lemmatization and stemming. So lemmatization transforms, for example, the word running into a base form, based on the root, maybe the Latin root of a word. Okay? So the word still carried the same meaning after lemmatization, whereas stemming is basically just removing the affixes without no regard to the word actual meaning. Okay, so there are important differences between lemmatization and stemming, and both are widely used. Again, in comparison, in conjunction with stop words, those words that are really common, like you, me, not, and the in text preprocessing. Okay, and now let's move on to the exciting part of generative AI for qualitative data analysis. What really generative AI brings to the table in comparison to the previous method that we introduced? I would argue the following, where I add the asterisk means that I'm not very sure. Otherwise, no, I would say, yeah, those points I think are pretty sure that are happening very quickly. One is scalability, that generative AI allow us to analyze vast data swiftly, which is impractical for manual text analysis methods. Okay. So here we can give an example of how fast it is. So in our trial, we do semantic analysis on an example of 17 transcripts. Each transcript is about 10,000 words, so 170,000 words in total to do semantic analysis, extracting the topics and do explanation and providing quotes and synthesize across the participant level and then at the study level. And for manually work, I don't know how long it's going to take. But most of you probably are doing qualitative analysis, so it's very labor intensive. But for us, we did that. The program that we wrote ran for about half an hour, and we paid about $15 for the computation on the cloud, and it's done. Okay. And later on, we'll see some of the results. Okay. And the second aspect is contextual understanding, which large language models are doing better. It is still, of course, probably not up to the expert level, but moved really quickly. And really pay attention to the nuances in sentiment analysis and topic modeling in comparison to traditional approaches. Enhanced accuracy, reduce human error. For example, in NER, recognition and the tasks, it can reduce a lot of human error, given the variations in raters, etc. It can integrate multiple methods together. We can do both qualitative analysis and quantitative analysis on the qualitative data at the same time, doing a variety of different approaches, looking at different angles. And then adaptability. The AI models continues to learn, improving the analysis over time, unlike the static traditional method. So the first time it didn't do a good job, but it can get better. Okay. So the key features of generative AI are the following. We just go very quickly because presumably you know those aspects pretty well. One is to create new content, learn from the data continuously, adapt across domains. For example, we can use generative AI to do art, literature, design, etc. Right? Doing math as well, although not very good. The generative AI models are interactive and responsive. Okay, it's like chatting with a machine, right? It can really form an innovation driver in creativity and problem solving. So there are many generative AI models, and here I put them into two categories, but of course, there are many other categories that don't fall into. So the first one is text generation models, for example, GPT model offered by OpenAI, cloud model offered by Anthropic, and there are about 700,000 models hosted on open source models hosted on Hugging Face. Most of them adopted transformer architecture. And there are image generation models, Midjourney, Stable Diffusion, DALL-E. They are not all focused, but we have separate research using those models. But today we are focusing on text analysis. No, large language model. Here, I'm going to give you some really quick, but hopefully, insightful demonstrations of how we use large language models to do qualitative data analysis. We're going to show you 3 examples. First, we're going to show you sensitivity analysis using so-called few-shot learning. Few-shot learning is just a fancy term of telling that I'm going to give the model several examples, and the model is going to do the sensitive analysis based on my examples. Okay. And the second, we're going to show you how you can use ChatGPT to conduct thematic analysis, ground theory, and discourse analysis. And we call them zero-shot learning because you provide no example. You just ask the model to do the job based on your prompt. And the third, we are going to demonstrate how you can use OpenAI API, the GPT-4 model, to identify and synthesize key themes and extract quotes from large volumes of interview and focus group transcripts. And for the first 2 demos, they are written actually in my book that published a year ago, so Supercharge Your Research Productive ChatGPT. In the book, I provide over 100 real-world examples covering 10 fields of research, from topic formation, hypothesis testing, all the way to disseminating starting findings. And today we are going to take a look of chapter 7, part of chapter 7, on how you can interpreting and analyzing qualitative data. Right? So this is the link to the book if you're interested. And now let's move on to, I have to switch a little bit to my PDF, which is just part of my book. Okay. Can you see my PDF open?
Yes, we can see that.
Great, great. Okay, thank you, Sarah. So here is a very simple sensitivity analysis, the sentiment analysis. I wrote the prompt to ChatGPT. Okay, everyone can do that, but make sure that you use GPT-4 model. As my research assistant, you will learn to identify 3 types of sentiments: positive, negative, and neutral, towards soda taxes in the US by examining the following example tweets. Afterward, I will provide you with additional tweets for you to label their respective sentiments. So I provide the first example. So this is why we call it few-shot learning, because we provide examples. The first tweet, this is original tweet. I support soda tax because they help reduce obesity and diabetes. Soda is not a necessity, it's a luxury. If you can afford to drink it, you can afford to pay a little extra for it. Okay, of course, this is positive. So after providing example, I say sentiment positive. Okay, so first example. As you can guess, the sentiment analysis works the best if you provide both positive as well as negative examples. Right? So therefore, the second one is negative. Tweet: soda taxes are unfair and ineffective. They hurt low-income families and small businesses. Don't change people's behavior just to make them pay more for their choices. Of course, this is negative, so we label them negative. And third one is neutral. The tweet is: soda taxes are a controversial topic. Some people say they are good. Others say they are bad for the economy and personal liberty. What do you think? Right? So this is neutral. Okay. So I provide 3 examples, and then I ask the machine to do the job. Please assess the sentiment of the following tweets. This one: soda taxes are a nanny state policy that infringes our rights. They are based on junk science and propaganda. They don't make us healthy. They just make us poor. And why I leave this empty? Because remember, any natural language processing model, any causal language model is doing task completion. So I ask the machine to do the completion for me, basically filling the sentiment. And the second, soda taxes are a smart way to fund health and education program. They make soda companies pay for the social cost of the products. They also encourage people to drink more water and juice. And sentiment. Hey, and look at the response here. This is machine response. I didn't do any modification. Okay, so this one, they just repeat the tweet and then sentiment negative. And then this doesn't do any repeat, do a repeat and then sentiment positive. Okay, so the machine tend to understand this pretty easily. But of course, in reality, when you have tens of thousands of tweets or social media posts, you don't do in the interactive way, right? You don't really type those in your UI in the ChatGPT. You have to use the OpenAI API to do that. Right? Okay, so that is sentiment analysis. And then let's move on to thematic analysis. Okay. So here, I write the prompt here. As a university researcher, you are conducting a thematic analysis of interview transcripts. These interviews feature Hispanic mothers of infant toddlers at risk of obesity, focusing on their children's feeding and sleeping habits. Okay, so that we are using some real data. And I give ChatGPT very specific guidelines what the ChatGPT should do. Your responsibilities include identifying and summarizing the main themes within the interview. To accomplish, please complete the following 3 tasks. First, craft a concise topic sentence that summarizes each theme. Second, provide a detailed explanation of each theme. And 3, select up to 3 unaltered original quotes from the transcripts that illustrate each theme. And then please adhere to those tasks and avoid including any additional information because ChatGPT sometimes is too chatty. Okay? Now let's take a look. So this is I basically just copy and paste the entire interview transcripts. Okay, I do not do any modification. This is just the transcript itself, with 2 speakers, the interview and interviewee, and then the response is here. Okay, theme 1, difficulty in feeding children healthy food, and this is the topic sentence. This explanation provided by the machine. It seems right, and then the quotes. I double checked all the codes. The codes, there's no hallucination there. Actually, by different token, I'm going to offer a different workshop on how the strategy to reduce hallucination. Really a huge topic, I would say, nowadays, because many people disbelieve large language models because of hallucination. But there are a variety of strategies that you can apply to reduce the hallucination by probably 95% to 99%. Okay, so we'll reserve that to a separate talk. And then those are the codes, and all those codes are really existent in the original transcript. And theme 2 is limited social support network. They provide a topic sentence, explanation, and quotes. Okay? So you can read them, but for the time being, we will just go through this quickly. And the theme 3 is important breastfeeding and sleep habits, etc. Right? So it seems that the machine tend to do what I ask the GPT model to do. Okay. So here, and then I just because the transcript is pretty long, so I segmented the transcript into 2 parts and feed them individually. Okay. But you can read the machine interpretation of the themes. But now let's move on to. So here is pretty lengthy. I probably chunk them into 3 pieces. And then I ask the model to consolidate all the themes, basically reducing the duplicates, etc. Okay, this is just a demonstration, but in reality, you don't do this probably in the chat interface. You are much better off doing that in the OpenAI API. Okay, that we are going to showcase a little later. And now let's take a look at the graph theory. So by no means I'm a qualitative analyst. Okay, so no, forgive my lack of understanding of graph theory and semantic analysis. So many of you probably are 10 times more experienced than me. But here I just showcase what the OpenAI could do. What are the frontier of doing this using AI. So I provide in this prompt. I said I have a set of interview transcript I would like you to analyze using graph theory methodology. And the research I give the research question. The research question guiding this interview is: what are the social, cultural, economic determinants that drive Hispanic moms' feeding practice and sleeping patterns? Okay, so use the graph theory methodology. Please help me analyze those transcripts in order to identify key concept, category, themes, etc. And I also provide the specific steps that I would like machine to take to do the analysis. The first is you need to code the transcript to open and axial code techniques to identify key concepts, and then use the code. Please develop a category and themes to capture the essence of the data, and based on the categories and themes, create a conceptual framework, and finally write it up. Okay, so you need to be really, really specific. And then I just provide the entire interview transcripts. Okay. And then let's take a look at the machine responses. So the response, step 1, it follows step 1, open coding of the transcript. So they have all these open coding terms. And then axial coding. And in the step 2, based on the coding, they develop the categories and themes. Those are the 4 categories. Those are the 4 themes. And then step 3 is to create a conceptual framework, and they explain this framework in some detail. Okay. with four bullet points. And then based on the theme, they start writing up the findings based on the research question. Those are the findings. Okay. For the time's sake, I will not really go into details, and you can judge whether the machine does a good job or not a good job. Finally, I demonstrate how you can use ChatGPT to do a discourse analysis. I have a set of 2 interview transcripts that I would like you to analyze using discourse analysis. The research question that guided the interview is, does the power recognized in doctor talk differ between institutional and domestic setting? So this transcript is very interesting because the 2 transcripts, the first transcript, a doctor talked to his patients, 80 years old older woman. And in the next transcript, the same doctor talked to his grandma, who consult with the physician some of her health problems. Although the 2 interviewees are of the same age range, about 80 years old older woman, but their interaction are very different because one is the patient, one is the physician grandmother. Okay? So here I provide both transcripts and I explain this in detail. What is transcript 1? What is transcript 2? And then I ask ChatGPT to do discourse analysis, first doing a power relation. Okay, examine how the language used in each transcript reflects and reproduce power relations between the doctor and the patient in each setting, and then explain the identity. Explain how language used to connect to the connection of individual and collective identity of a doctor, and then explain the social norms and the values, etc. Explain the ideology and the context, and then other themes and patterns. Those are the traditional ways that we do discourse analysis, and then finally, of course, write it up. Okay. And then I provide both transcripts. The first one, doctor with the patient, the other doctor with his grandma. And what the machine answered, I think, quite interesting. Makes sense to some extent. So finding from this discourse analysis, power relation here in transcript 1, the doctor is portrayed as a more authoritative and knowledge than the patient, whereas in the second transcript, the doctor convinces grandmother in a more informal and relaxed manner with less emphasis on authoritative language, right? And then talk to identity, social norms, ideology, context, other themes, etc. Right? So you can read the rest, but for the time being, that would be some teaser for you to experiment with. Right? And now let's go back to the final part of the presentation, which we talk about here. All right. We'll talk about our way of analyzing a huge amount of transcription data, transcript data. So we all know analyzing qualitative data, especially large number of transcripts from interviews and focus laboratories, and also very time consuming. We asked 3 questions. How can generative AI help identify and extract the themes relevant to the research questions? How they can provide detailed descriptions, and how we can extract relevant quotes. Okay. So we followed a 4-step approach using OpenAI API. The first step is chunking the transcripts, and then followed by extracting relevant themes, and then followed by synthesizing themes at the participant level, because a study may have multiple participants. And then finally, we integrate the themes into the study level. Okay, so let me illustrate how we do this. First, we need to chunk the transcript because the transcript usually is too large to fit in the language model. So even if you can feed the entire transcript into language model, don't do that in one go, because we will have the so-called lost in the middle problem. We don't have a lot of time to explain what is that, but a very simple explanation is that, well, when you read a huge number of transcript, you only remember what's beginning, what's the end, but you forgot what's in the middle. Okay? So therefore, you need to chunk the transcript into probably 1,000 words, 2,000 words each. And then we need to extract relevant themes from each individual chunks, right? Using large language models, using the prompt engineering that I showcased in the UI interface. Okay? And after that, we synthesize the themes at the participant level. So if a participant have a transcript of 10,000 words, we chunk them to 1,000 words each, and we generate the themes for each chunk. So we have 10 chunks of themes, and then we integrate those themes for the same participant, right? Reducing duplicates, combining different themes together, etc. And finally, we synthesize at the study level. So say if a study has 17 participants, for each participant, we have a set of themes, and then we integrate them together, reducing duplicates, combining themes as necessary to form an overall study level themes. Okay, so that is what we did. We wrote our own algorithm to implement this. And we are writing an article, and later on, we are going to open source our model so that everyone can use it. And how we evaluate the generative theme, whether the themes are any good, right? Evaluating qualitative studies can be really tricky because, well, it's very subjective. And we want the themes to be close to researcher-identified themes and of high quality by public health research standards. And we do not want themes to be vague and possible hallucinated by the models. Okay? So those are the criterion. So we have 5 independent human evaluators of brilliant doctor master students. And each tasked with evaluating GPT-generated themes on 11 published qualitative public health studies. So the ground truth would be the published studies, the themes identified in those studies. And the model predictions would be the themes generated by the models. And they are going to do a head-to-head comparison between these two to see what are the gaps. Okay. And we used 4 core components, 4 criterion. The first criterion is alignment. Do the GPT-generated themes match the manuscript published themes? The succinctness, are GPT-generated themes repetitive in nature? And third, the qualitative explanation, are they vague or are they descriptive? And finally, qualitative quotes, are the quotes made up or contextually relevant? Okay, so each has a Likert scale from 0 to 4, and we have 5 evaluators to independently evaluate that. Okay, so for themes alignment, 0 to 4 on the scale. So on the left-hand side are the manuscript listed themes. Okay, on the right-hand side are GPT-generated themes for one of the 11 studies. So this seems to be pretty good for this particular study. On Drupal's on physical activity from university staff and students. So this article, 3 out of 4 evaluators give a rating of 4. So this you see a pretty good match, but not so good for this one. So this one is the feeding practices from Latinx mothers of children at risk of obesity. As you can see that there are only probably 1 or 2 themes that matches. The other themes don't match. Okay, so in this case, 3 out of 4 evaluators give the rating of 1. And for succinctness, again, on the physical activity paper, for this particular paper, the themes seems to be very succinct in their own right. So they have 4 out of 4 evaluator give a rating of 4. But for this study, 2 out of 4 evaluator give a rating of 2 because some of the, for example, GPT-generated theme of sleeping routines and nighttime walking, they can be combined into a single theme. Okay. And for qualitative assessment, qualitative explanations, for this physical activity study, the explanation is pretty good. For example, the theme is influence of social support and university environment. Explanation is the social environment, including friends and colleagues, in conjunction with availability and quality of university-provided physical activity facilities, profoundly impact participant physical activity. This underlies the need for university-centered social economic interventions, right? So all evaluators give a rating of 4. But for this one, sleeping habits, not so good. The explanation seems to not be relevant to the theme. So most evaluators give a rating of 2. And finally, for relevant quotes, so here, in this theme, the quote is very good. This is a very nuanced theme, actually. Influence social support university environment, and the quote is, you feel, okay, I got a workout partner, let's go ahead and go with it, rather than you don't really feel as motivated if you're going there by yourself. Okay, so the code seems to be pretty relevant, but for this study, it's lacking relevancy. Okay, actually, it extracted the wrong codes. It should be actually the codes from the interviewee, but actually it extracted codes from the interviewer. Okay. And then overall evaluation quantitatively, and we estimate the ICC, the inter-rater reliability score, ranging from 0 to 1. 0 means terrible, 1 means perfect. And we have relatively good score. The overall score is 0.845, is considered as pretty high in terms of the inter-rater agreement regarding the final score for each categories. Okay. And regarding the scales from 0 to 4, the mean rating for each of the 4 criterion, the alignments, the symptomness, qualitative explanation, relevant quotes, they range from 2.75 to 3.41. Okay, so they are not super good, but I would say they are acceptable, right? Okay, so the conclusions, the large language model can assist researchers in extracting themes from qualitative interviews. And the theme generated from LLM can be used to complement field-specific domain knowledge, for example, business intervention, patient care, you name it. And large language models and other modern AI tools become increasingly powerful. So this probably is only the very beginning, right? If today's performance doesn't surprise you or didn't impress you, well, no, I would say look at from the evolutionary view and the potential future of large language model in assisting quantitative analysis. So that's for the a very fast-paced overview of what large language models and the generative AI models can do for qualitative analysis. But of course, it's not the end of the story, right? Because AI is not only generative AI, it's not only large language models, but comprise many other domains. So if you're interested in knowing more about it, you are more than welcome to join my semester-long certificate program on artificial intelligence. So this year we are going to offer this for the 3rd time, and we have trained hundreds of participants on how to leverage the power of AI to do research and beyond. Okay? So the program is provided here, is completed online via Zoom, 15 weeks in total, 3 hours per week. Every week you get weekly project-based assignment. And the registration is going to open by the end of May, and the program will run from early September to mid-December. And we are going to go over from the very beginning, from the overview of AI, Python programming, Python to do data analysis, and then to traditional machine learning. We will cover a variety of topics on machine learning. And then we'll move on to deep learning afterwards. Okay. And the course format would be a lecture plus hands-on exercise sessions, and we'll provide all the code and weekly assignments. Okay. And finally, today's video recordings, you can find them on my website. So scan the QR code and go to this web link. And we have a lot of other programmings going on besides the open classroom. And you can find all the video recordings of my previous lectures, the open talks here on my website. Okay. So I apologize for the rush, but I'm glad we have some time for questions. Thank you.
Yeah, thank you, Dr. An. And I'll have you leave your screen up just for a second in case some of the questions might need you to go back to some of your slides. But just a reminder, this was being recorded and will be shared. Dr. An has a couple of places where the recordings are shared. And then we also have on our professional development website where those things will be shared as well. And he just has a wealth of resources. So I hope you dive into those. So first question I'm going to try to get to. So this person says, I know that sentiment analysis is typically applied to textual data, including sentences and paragraphs, but they are curious about its applicability to responses in checklist format. So if participants select words from the multiple adjective affect checklist, which comprises approximately 132 adjectives in response to a question, can sentiment analysis effectively process these selections even when they don't form traditional sentences or paragraphs?
Yeah, this is a great question. I would say, yeah, this is relatively unconventional, but I've seen this in practice. So there are some prompt engineering needed. Basically, you need to come up with prompts to guide the large language model and be very specific about the end product of this model, and then use the few-shot learning technique that I showed you, right? Providing examples, both positive cases and negative cases, to help situate the large language model and understand your request. I think it's quite doable. Now think about this way. Now what the model, the large language model and modern AI are doing and just try to mimic our cognition, right? So if human beings can understand it, no, usually the machine can understand it. So no, think about we are just trying to use the machine to replicate our cognition process.
The next, you're great. The next question is more about protecting information. So when we're using AI as a tool for analysis, are there any best practices for making sure that, you know, public health information, medical records, other protected information stays protected? And I guess the flip side to that question would be, are there risks in using AI around protected information being, you know, inappropriately shared?
Yes, this is a very typical question. I appreciate that you asked it. Very important. I'll be really fast, but you can later on check the details. Two comments. The first one is that yes, there is of course risk, and you should not actually upload any of the sensitive information, the patient information, the information with any no conflict of interest, etc., to the closed source UIs, for example, OpenAI, cloud, or any other platforms, because those data can be used to train their own models. Right? And the solutions would be one, that you use the HIPAA compliance the large language model, for example, the sandbox provided by WashU. And you can, if you use the ChatGPT model hosted there, is free of risk, right? Because the data never go to the cloud. The data only hosted at a secure place at WashU. And second, if you're versatile, if you learn enough AI, actually you can build your own repo of the large language model and host locally in a trusted cloud or in your computer machine, local machine, so it's never leave your space. Okay. Yeah, great question.
Okay, didn't know all that. I always learn something new with your presentations. Okay, let's see if we can get to a couple more questions here. All right, this question is about hallucinations, which we've been hearing a lot about recently, just in the media coverage of AI. And we know there are a lot of documented hallucinations within AI use. How can you be sure that your analysis of textual data by generative AI is actually a valid analysis? So, I mean, I guess if you personally were doing something, what are the the top couple of checks that you would go to make sure that a hallucination is not occurring?
Yeah, exactly. This is a great topic. But no, I'll defer because I have a dedicated talk to that topic. So we will spend 1 hour to give you hands-on exercise on how you can reduce hallucination by 95%, 99%. And there are a lot of techniques involved, from as simple as prompt engineering to as complicated as fine-tuning and use RAG, so-called the retrieval augmented generation, to ground the large language models in truth in the data that you provide. So I'll provide the workshop information. Actually, it's on my website. So I would highly encourage you to attend this event. They'll just register there, and everyone is free to attend. Doesn't matter whether you're WashU affiliate or not. So let me share with I can't really see everyone.
I'm sure there's a lot of people here who would love to attend that.
Yeah, so that will be
there it is.
Hallucination workshops. Okay, not hallucinating. Hallucination workshops. Okay, so attend that, and you get hopefully a more satisfactory answer.
Great. And I'm going to try to squeeze in one more of this one that just came in the chat, because I think it's a good one to end on, is just like, ChatGPT and AI technology is growing so rapidly. Will the information in your book be relevant for at least a little while longer? And I mean, maybe we can expand that question to just kind of say, or to be about, like how fast is this stuff becoming obsolete or maybe out of date, and how can you best, as a researcher and an AI practitioner or user, keep up on, the latest knowledge and the latest practice?
Yeah, this is a great question. First, I would say the AI technology evolves so quickly that it's a full-time job, right? To just survey the prevalent technologies. So things got old really fast. One is technology. Technology going old really fast, whereas the philosophy stay a lot longer. So the book is not about actually the technology, it's the way that you think, the way that you approach the problem in partnership with the machine. Always so-called prompt engineering, right? It is that way that we communicate with the machine that's going to stay for a while, unless the machine can read our mind and don't use language. That's another story, right? But as long as the machine understand us through the language, then the book is going to be relevant. So that is what we try to talk about. It's not about a particular technology. It's not actually about ChatGPT. It's more about the way we think in conjuncture with the machine to form a machine-human partnership.
Awesome. Thank you so much. Well, we're out of time. Last time I'll share it, the QR code, that's where the recording is going to be shared tomorrow, as well as Ruopeng's various sites as well. So you can always rewatch and share. And then we hope that you will join us for a deeper dive into these topics with AI, with Ruopeng on AI. We have 2 workshops, a part 1 and a part 2. You can sign up for one or both this summer, both in August. I dropped links to these in the chat. And then, of course, the advanced learning certificate, if you really want a deep dive into learning AI use for applications for health data. That's registration is coming very soon, and the dates are this fall. So thank you so much, Ruopeng, for sharing your time and expertise today. And thank you to everyone for joining and all of your great questions.
Thank you, Sarah and Zizi. Thank you, everyone. Take care. Bye.
Everyone.